Hi, this is the third video in the playlist on working through this particular paper. Now if you follow the link below you'll be able to download it. It's the AQA higher level specification, and this is paper 2, the calculator paper. We finished on the last video at question number 14, so we're going to start today from question number 15 onwards. Please do have a go at each of these questions. Stop the video, have a go at them, and then compare your solutions. Okay, so let's move on then with question number 15. Okay, it's a bit of a tricky one really, but it's basically the realization that actually there are, if we're looking at how many different 4-digit numbers could she pick, well, it's really, if we're looking at the number of digits between 1,000, 1,000, which is a 4-digit number, okay, and 999, which is the final digit number, then actually, if it's inclusive, we're saying that there are 10,000 minus 1,000, so there's actually 9,000 numbers between 1,000 and 9,999 inclusive. Okay, well in that case, if we're looking that all those numbers are, the 9,000 numbers is a multiple of 5, it has to be a multiple of 5, then it would be 9,000 divided by 5, and that's going to equal 1,800. So there's actually 1,800 different full numbers that you could pick that would all be divisible by 9. I think the difficulty with this particular question, and I found this a bit of a struggle myself, is actually working this bit out, that this is an inclusive number, so therefore it's the difference between those two, which is 9,000 altogether. Okay, I hope that's been alright for you. It is a bit of a tricky start to this particular video, but we'll move on then to question number 16. Okay, so question number 16, prove that expression is an even number. Well, in order to prove it's an even number, it needs to be a multiple of 2. Okay, so probably the easiest way of doing that is to actually factorize the top and factorize the bottom. So what we're going to do is we're going to look at the top, and I'm going to factorize by, if I look at this, the common number is going to be 6, because 6 will divide into 6 and into 30, so it's going to be 6. And then I've also got c cubed and c there, so actually the common term to both of these is going to be 6c, so I can write that out then as 6c and then 6 squared plus 5. So what do I do to 6c to get 6c cubed? I multiply it by c squared. What do I do to that to get that? Well, I multiply by 5. Okay, so again, please do revise factorization. It's very important for these types of exams. Okay, and then the bottom, I can do exactly the same. I'm just going to factorize, but in this particular case, I can only factorize by 3, but I do end up with c squared plus 5. Okay, well, that's really good news, because then I can just get rid of those two and divide through by c squared plus 5. So in other words, 6c divided by 3, well, that's going to be 2c, okay? And basically all even numbers are a multiple of any number, okay? So if I write all even numbers are a multiple of any number, okay, so a multiple of 2 rather. Okay, so if you think about any number, let's think about 27. Okay, well, if I multiply that by 2, I get 54, okay, which is an even number. Let's think of another number, let's say 12. Well, if I multiply that by 2, I'm going to get 24, okay? If I multiply 13 by 2, I'm going to get 26. Okay, so every single number, if I multiply it by 2, which is what I've done to 2c, then it must be an even number. Okay, so therefore, I'll just put that, therefore c is an even number. Okay, I hope that's been all right for you. Do have a look, please, at algebra proof. There is a playlist on the channel, and that will give you some idea of how to work with these types of proofs. Okay, let's move on then to question number 17. And question 17 is okay, but you've got to remember that actually it gives you quite a bit of information that you need. It's not just a straightforward speed equals distance over time, okay, although that's part of it. What I suggest you do is you write at the very top of your answer speed equals distance over time. Okay, so let's have a look at that. Well, what it says is it takes 365 days for the Earth to travel once around the Sun, and the distance from the Earth to the Sun is 93 million miles. Okay, so let's just have a look at that. We've got the Earth and we've got the Sun, and the distance between the two is 93 million miles. Okay, well, effectively you can imagine that the distance that this the Earth travels around the Sun is actually in a circle like that. Okay, it does actually tell you the Earth travels in a circle with the Sun at the centre. So in other words, the circle has a radius of 93 million. Okay, so to work out the distance, we've got to work out this circumference around the outside here. Okay, well, let's have a look at that then. So distance travelled. Okay, so the distance that the Earth travels. Some people will use 2 pi r, which is what I'm going to use. Some people will use pi d, but essentially it's the same calculation because 2 times r is the diameter. Okay, so some people will write this as pi d. I tend to use 2 pi r. Okay, so if I write that out, it's 2 times pi times the radius, as we mentioned before, of 93 million. Okay, so if I then put that into a calculator, I'm going to write out all the digits here. It's 584336233.6, but practically you probably wouldn't write that out. What you need to do is just sometimes in a calculator you've got an answer function that will allow you then just to store that answer ready for you to use when you plug it into this formula, which is what we need. Okay, so the speed equals the distance, which I'm just going to write answer, okay, divided by the time. Now the time it's taken 365 days to travel around, but they want our answer in miles per hour, so be very careful about this. This is a 4-mark question, so it's taking a little bit of working out, but it's going to be 365 days multiplied by 24 hours in a day. Okay, and if you work that out with your calculator, you're going to get an answer of 66705.04949. Okay, so we'll round that up to a whole number, I think, and we'll just leave that as 66705 miles per hour, and actually that's fairly accurate. Okay, so I hope that's been all right for you. It's a 4-marker, so it's not nearly as straightforward as you think it's going to be. You do need to make sure that you've got your units absolutely correct for these. Okay, and then on to question number B, or part B of this. It says it actually takes 365.25 days for the Earth to travel around the Sun, and that's actually because the way that we counterwrite that is we have leap years every 4 years. Okay, so how does this affect your answer to part A? Well, you could, if you want to, just write the speed will be slower. Okay, now just to prove that is that if you what I would do is, we know this is this answer at the top here is some big long number, so I'm just going to put it in standard form, or a fairly close approximation of standard form. I got 5.8 times 10 to the power of 8 is close enough to demonstrate that if you divide by 365.25 times 24, you're going to get an answer of 66164.73, okay? And if I do the same calculation, but I do 5.8 times 10 to the 8 divided by 365 this time times 24, which was our original proposition, then I'm going to get an answer of 66210.05. So if I've got that extra quarter in here, it's actually going to be just marginally slower than this one over here. So if you wanted to, you could kind of prove it because it's a calculator paper, then you're absolutely fine to do that. Okay, so let's move on to number 18, which is one of those questions that AQA like such a lot. And they say that this is a formula, n is a positive integer, okay? And the value of t is always greater than 1 because n minus t squared is always greater than 0. Well, comment on her statement. Okay, it's a 1-mark question. I think it's one of those questions where if you don't get it straight away, then come back to it later on. But basically what we're saying is that this n minus 6 squared could be 0. And the reason it could be 0 is because n could equal 6. Okay, so it's still a positive integer. Okay, it's still, yeah, so I can put it into here, 6 minus 6, well that would be 0, and 0 squared is going to be 0, so it could be 0. So, okay, it could, in other words, the value of t then could be, could equal 1. So it could be 0, which is this in here, plus 1, which is this little bit here, so t could equal 1. So not always greater than 1, it could actually equal to 1. One of those questions I think that you need to maybe come back to if you wanted to. Okay, so it's a similar sort of thing. What is the only value of t that is a square number? Okay, well it's when n minus 6 squared equals 0, which is what we did in the last part of it, part A, and it's say then t equals 1, and t is actually a square number, or rather 1 is a square number. Okay, so I think it's one of those questions where it's just a case of just working through a couple of examples and making sure you satisfy yourself that you're answering the question in accordance with what they're looking for. Okay, so let's move on then to question number 19. So 19 is an inverse function question. Okay. Now there is a technique of doing this. Again, I'm fairly sure that people are able to use different methods. That's absolutely fine. So what we do, or what I've done before, is, and if you have a look on my playlist, there is a playlist on inverse functions. I'm going to change that to y. So y equals 3x. Okay, and then I'm going to make x the subject of this particular formula by dividing through by 3. So I get y over 3 equals x. Okay, and then I've got to then swap them over basically. So if I swap them over the other way, I can say x over 3 equals y, and then I change that y back again to function of x. Function to negative 1 of x. So x over 3 equals function minus 1 of x. Okay, so it's actually going to be this particular expression here. Okay, so you might need to have a look at the playlist on working with inverse functions in order to go through that particular method. There are, again, I'm aware there are other methods that people do use, but that is a good way of doing it if you're able to follow that, and do have a look at the other examples. Okay, so let's move on to question number 20. Y is directly proportional to the root of x. Okay, work out the value of A, so it's this value here, okay? So what we're saying is that y is directly proportional to the root of x, okay? Well, what I'm going to do is I'm going to write that as a formula. I'm going to write y equals k root of x, okay? And then what I can do is I can use these values that I've got here to be able to determine the value of k, okay? So I'm going to say when y equals 2, x equals 36. So in other words, when y equals 2, x, or the root of x here, is going to be 6. So k is 2 over 6, which is the same as saying k equals 1/3. So now I can actually write my formula out as y equals 1/3 root of x, okay? And then really it's just a case of plugging this number in. Now in a particular case, if I'm looking at this one here, which is what they want me to do, I've got y equals 5 equals 1/3, that's the root of a. Okay, so in order to find out a, what I need to do is I need to square both sides. Okay, so square both sides. Okay, so if I look at 5 squared, well, that's fairly easy, that's 25. Okay, now if I'm squaring this, what I need to do is imagine that I've got it in a big bracket, and I need to square both terms, okay? So 1/3 squared, well, that's the same as saying 1/3 times 1/3, which is 1/9. So that's 1/9. And then the root of a squared, well, that's just going to be a on its own. Okay, so I've then got 25 equals 1/9a. So if I multiply through by 9, what I end up with is a equals 225. Okay, so a little bit of working through here. It does take a little bit of time to kind of get your head around what it is they're wanting you to do, but once you've done that, you should be able to work out this value of a by just using normal proportion type rules and also algebra rules to be able to isolate this value of a, which is what we're looking to do. Okay, I hope that's all right. So let's move on then to question number 21. Question number 21 is about a company making boxes of cereal. Okay, it's all right, it's not too bad a question, but it does require you just to work through fairly methodically, okay? Now it says a company makes boxes of cereals. Boxes usually contain 450 grams, okay? So what I'm going to do is I'm actually going to work out 450 grams of cereal, okay? So, and then I'm actually going to make it a price. It just makes it much easier for me to actually put it into a bit more real world. Okay, so I'm going to say I've got option A and I've also got option B. Okay, so option A, well, I get 450 grams normally, but rather than 450 grams, I get 20% more. Okay, so if I get 20% more, then what I can do is I can work out 20% of this, which is 90 grams, and add it to this. Okay, so for option A, I've got 20% of 450 equals 90. Okay, so I'm actually getting 90 grams more cereal. So actually for option A, I'm going to get 540 grams. Okay, so that's 450 plus 90, and if I add those two together, I get 540. So I'm going to say I get actually 540 grams. Now what I'm going to do is I'm going to say, well, actually, I'm just going to use an arbitrary price. So I'm going to say I'm going to get that for £1. Okay. I don't know how much it costs for this particular type of cereal, but let's say it costs £1 or $1, however you want to do this. Okay, so don't forget that that £1 is the same as 100 pence, okay, or 100 cents, whichever way you want to do. Okay, so on this one, option B, I've got the usual amount, which is 450 grams, but I get a discount of 15%. Well, in other words, I get then 450 grams for a discount of 15%. So actually I get 450 for, rather than a pound, I get them for 85p, because 100 pence minus 15 pence is going to be 85p. So now I've actually got two relationships. I've got 540 grams for 100p, or I've got 450 grams for 85p. Well, I can use that then to work out the price per gram. And that just makes it a little bit easier for me, and because this is a calculator question, I can do it fairly simply by just simply feeding into my calculator that if I get 100 pence for 540, or I get 85 pence for 450 grams, then the price per gram for the left-hand side for option A is going to be 0.185185, and that's actually recurring. Okay, and for option B, it's going to be 0.18. Okay, 18888. Okay, so actually option A, although it's only a very tiny amount, is marginally better. Okay, you can see that's a smaller number than this one over here. So actually option A is the better value. Okay, now there might be other ways of doing this. I think price per gram kind of works out for me, but if you wanted to work it a slightly different way, maybe use maybe rather than £1 or 100 pence, you could just do, I don't know, £1,000 or something like that, if you wanted to make it a bit more realistic for, you know, for yourself, or change the values. That would be absolutely fine. There are a couple of ways of doing these sorts of questions. Okay, so let's move on then to question 22. Okay, and that's just asking us to look through and work out some information from a histogram. Okay, well, with a histogram, you've got a little bit of information here. Now, it's a bit tricky because we're going to be showing this actually on the video, but if you do print off the paper, it will give you a bit more information. The reason it's going to be a bit tricky is actually this frequency density along here is not fantastically easy to see on the video, but hopefully we'll be able to get it across okay. So the first bit of information, which as I've mentioned before, always try to find the first bit of information and then act on it. So it says there are 22 members with ages in the range of 40 to 65. So what we're saying is this block represents 22 members. Okay, so what we have to do is we have to use frequency density equals frequency over class width, and what this will do is it will allow us to work out the frequency density for the members between 40 and 65. And the way we do that is we say the frequency, well, we know it's 22, and the class width is the difference between 40 and 65, which is 25. So in other words, the frequency density is going to be equal to 0.8. All right, so if I then just take my ruler and measure this across here, what it means is this particular line here is the same as 0.88. Okay, now this is where it's just a slight difference, I think, because what we need to do in order to work out the number of members in the age range of this to this, what I need to do is find out this value of frequency density over here. Okay, now in order to do that, you need to maybe really look very carefully at the number of boxes there are on here, and what you'll find is there's actually 11 boxes. There's 11 boxes between that point and this point here. So in other words, that each of these boxes is 0.08 as a frequency density per, I'm going to call it gap, but you could, if you want, write per box, okay? It just gives me a much better way of being able to determine the frequency density, okay? And then it's really a case of looking at this at the top here, and if you add them all up and work your way through, what you'll find is that this frequency density at the top will become 2.4. Okay, I'm just going to move this video down a little bit so you can see it. Okay, so that's there, and you'll find then that this point here will be 2.4. So I think the difficulty with this is kind of looking very, very carefully at the types of axes that there is here and how this axis has been broken up. Okay, so do be a little bit careful with that one, and it's the bit I think that takes all the time with this particular one, because once you've got that 2.4, what you can do is you can say, well, I've got a frequency density equals frequency over class width again, and they're asking us to work out the number of members, in other words the frequency for this class width. Okay, well, the frequency density is 2.4, and that equals the frequency, which is what I'm looking for, divided by the class width, which is the difference between this and this, which is actually going to be 15. And if I multiply that across, I get 36 equals the frequency. Okay, so in other words, the answer to this particular question is that there are 36 members, and they are in the age range of 25 to 40. Okay, so 20, they're greater than or equal to 25, or they're less than 40. Okay, so the difficulty with that one, I think, was trying to kind of work things through a little bit. What you could do is that one of the ways maybe is you can count these little blocks, but you could also say is that actually if I look at that, I got 5, 10, 15, 20, 25, 30, and actually if each of these blocks along here is 0.08, what I could do is I could say, actually, well, that's the same as saying 30 times 0.08. And if I plug that in my calculator, that's going to give me 2.4. So actually, I know that this 30 is equivalent to 2.4 over there. So it's entirely up to you how you do that, but the key issue with this particular question is getting hold of that value 2.4 of the frequency density. Okay, so we're going to leave it there. I'm going to move on to the next video, which is from question number 23 onwards. If you've got this far in the playlist, you're doing extremely well, particularly because this is quite a challenging paper. If you do get any problems, please don't hesitate to put them in the comments below. I'll always come back to you, and I hope that's been useful for you, and I look forward to seeing you inside the next video.